Comprehensive Survey on Abstractive Text Summarization. Abstract. Over the past few years, we have seen the rise of automation for the purpose of human convenience. Using ML learning approach, we inch ever closer towards achieving a general-purpose AI. The field of artificial intelligence, AI, can roughly be divided into three parts, namely machine learning, ML, computer vision, and natural language processing, NLP. NLP involves the understanding and handling of human language, of which automatic text summarization is an important part. Text summarization is the process of shortening a lengthy document into a short summary. It creates fluent and coherent information while maintaining the context, meaning, of the information. It is a difficult task for human beings to generate a manual summary since it requires a rigorous analysis of the entire document. In order to reduce human efforts and time, automatic summarization techniques prove to be helpful. Text summarization has broadly two techniques, namely extractive text summarization and abstractive text summarization. Extractive technique relies on extraction of keywords, whereas an abstractive text summarization technique utilizes the principles of deep learning to generate the required summary. Keywords text summarization, extractive text summarization, abstractive text summarization. Introduction. Text summarization is the process of reducing the size of the original document while preserving its original information, and the summary generated is less than half of the main text of the original document. Summarization can be seen as a two-step process. The first step is the extraction of vital concepts or sequence formation from the source text by building associate intermediate vector or file of sorts. This step may also include any pre-processing required to be done on the text, including tokenization, tagging, or otherwise. The second step uses this intermediate file to generate a summary. News Blaster can be considered as an example of a text summarizer that helps users to find the news that's of most interest to them. The system has the ability to collect, cluster, categorize and summarize news from multiple sites on the web on a daily basis. A summarization machine can be viewed as a system that accepts either a one document or multiple documents or a query as an input and can extract or abstract a summary based on that input. Literature survey. Recent advancements in technology have enabled us to use ML models and perform exceptionally well in tasks unusually performed by humans. Higher computational power has empowered the use of complex, sometimes nonlinear models to be tasked on tasks such as text summarization, where they yield exceptionally high accuracies, sometimes even better than humans. Previous researches have introduced various summarization techniques which are cited in this section. Most of the researches concentrate on sentence extraction rather than generation for text summarization. Automatic text summarization, as aptly mentioned in Marathe et al. 4, is the task of automatically producing a concise and fluent summary without human intervention. This is achieved by a machine using various techniques, some of which incorporate NLP and deep learning, neural networks, as the base. There are two base divisions, extractive summarization and abstractive summarization. Kaiser, Shahzad and Ali, et al. 3, the use of term frequency inverse document frequency, TF-IDF, is discussed in examining the relevance of keywords to documents in corpus. Extractive text summarization uses a statistical-based approach to select important sentences or words from the document. Statistical approach can summarize the document using features like term frequency, location, and title, assigning weights to the keywords and then calculating the score of the sentence and selecting the highest scored sentence into the summary. The study is focused on how the algorithm can be applied to a number of documents. First, the working principle and flow which should be followed for implementation of TF-IDF is illustrated. Secondly, to verify the findings from executing the algorithm, results are presented, and then strengths and weaknesses of TF-IDF algorithm are evaluated. This paper also tackles such weaknesses. John X. Chu, Hongjun Yoon, et al. 5, we see an implementation of extractive summarization using convolutional neural network, CNN, for extracting ICD-03 topographic codes from a corpus of breast and lung cancer pathology reports. The purpose was the extraction of information from the export and therefore helps in faster understanding of a report. However, the basic task was to extract words from the document and place them and not to consider the grammatical nuance, flow of words, sequences, and carry over the context. Alexander M. Rush, Sumit. Chopra, et al. 11, we see the use of long short-term memory, LSTM, 11 as a base unit in an encoder-decoder model for summarization of news articles. Ramesh Nalapati, Bowen Zhou, et al. 7 introduces a model called sequence-to-sequence, SEQ2-SEQ, proposed in 10, which makes use of an encoder-decoder arrangement with an attention mechanism for summary generation, which again makes use of LSTM 11 as its basis. Abigail C., Peter J. Liu, et al. 6, we see an implementation of a pointer generator network which utilizes a pointer network 9 with our traditional approach and 6 for a decoder. Alexander M. Rush, Sumit Chopra, et al. 11 proposes a more data-driven approach as compared with the traditional generative approach. Using the model described in 7 as a base, this paper draws a parallel between a convolutional encoder and neural network language model, NNLM, encoder, as compared to a traditional LSTM11, and an attention-based encoder. 2. Abstractive text summarization. Abstractive summarization is a more efficient and accurate in comparison to extractive summarization. It can retrieve information from multiple documents and create an accurate summarization of them. Its popularity lies in its ability of developing new sentences to tell the important information from the source text documents. An abstractive summarizer displays the summarized information in a coherent form that is easily readable and grammatically correct. Readability or linguistic quality is an important catalyst for improving the quality of a summary. Abstractive text summarization method generates a sentence from a semantic representation and then uses natural language generation techniques to create a summary that is closer to what a human might generate. Here we are concentrating on the generative approach for abstractive text summarization. Since the human language is sequential in nature, it is found that RNNs and models based on them have a higher performance as compared to other approaches. Sequence to sequence, SEQ to SEQ, Ilya Sutskever et al. 2014, is one of the base models in abstractive text summarization. It turns one sequence to another, e.g. machine translation. It achieves this by the use of DNNs. This approach specifically uses LSTM to avoid the problem of backpropagation and for long carry of sequences. The output of one cell is the input of another and so on. This allows it to learn the sequence through a sentence. It normally employs encoder-decoder architecture. The encoder turns an input into its corresponding hidden vector containing the item and its value. This hidden vector is passed on to the decoder which reverses the process, i.e. turning the hidden vector into a corresponding item output utilizing the previous output as input. SEQ to SEQ models, see Fig 1.10 have been successfully applied to a variety of NLP tasks, such as machine translation, headline generation, text summarization, and speech recognition. Inspired by the success of neural machine translation, NMT, Vedant et al. 2014, introduced the concept of a attention model, which introduced a conditional probability at the decoder and effectively allowing the decoder to decide which part of the source input to pay attention to. This should a significant performance boost in comparison to the base Indus model. The dataset used was WMT. Rush et al. 11 further proposed a neural attention SEQ to SEQ model with a neural network language model, NNLM, attention-based encoder and a attention-based beam decoder to the abstractive sentence summarization task, which has achieving a performance improvement over previous methods. The model was trained on Duke 2003, Duke 2004 and GigaWord. Chopra et al. 9 further extended this model by replacing the feed-forward NNLM with a recurrent neural network, RNN. The model is also equipped with a convolutional attention-based encoder and a RNN, ELMAN or LSTM, decoder, and outperforms other state-of-the-art models on a commonly used benchmark dataset, i.e., the GigaWord corpus. Ramesh Nalapati et al. 7 introduced several novel elements to the RNN encoder-decoder architecture to address critical problems in the abstractive text summarization. They also established benchmarks for these models on a CNN/Daily Mail dataset 16, which consists of pairs of news articles and multi-sentence highlights, summaries. These applied optimizations have led to further increase in performance. The problem of automatic text summarization is an old problem with attempts and explanation going back a decade or two. Due to the introduction of powerful hardware and the resulting increase in computational power, we can implement the more computationally hard algorithms to achieve the result. Hence there is a gradual incline towards abstractive summarization techniques utilizing nonlinear models, deep learning, rather than the statistical, but computationally less expensive, extractive summarization techniques. While generating an abstract using abstractive summarization methods still remains a difficult task. Abstractive summarization methods produce more coherent, less redundant and information-rich summary. Due to the above reasons, the study of abstractive summarization techniques proves to be more useful. Acknowledgement. The author acknowledges the research done by the researchers referred in the paper for their useful research and in sharing their methodology. The author also acknowledges the efforts provided by AS. Professor Mrs. Kirti Wanjale towards guidelines related review work and proofreading of the paper.